So, quick revision from syllabus. We completed the last session, we completed till topic 9, which was about the periodic table. And today we'll discuss topic 10, the properties of the metal. You should be able to list the general properties of the metal. What are the general properties of the metal? As you can see, that most of the metals have high melting and boiling point. They can conduct heat and electricity, and they are malleable because their layers can slide past or slide over each other. Then describe general chemical properties of metal. Example, reaction with dilute acid and with oxygen. So reaction with dilute acid, not all of the metals react with dilute acid. When we write the reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So when we check the reaction with dilute acid, till lead, they can react with dilute acid. They can react with acid if we add an acid. And here when we refer acid, it means we are talking about dilute acid. So they can react. But for copper and lower in reactivity, there is no reaction. Does not react. And when metal react with acid, the result is a salt and hydrogen gas. So we'll see bubbles, fizz. And when metal react with oxygen, it will form metal oxide. If it is group 1, 2 or 3 oxide, it will be a white solid. If it is a transition element is there, then it will be a colored metal oxide. Identify representation of alloy from a diagram of structure. So you should be able to distinguish between, from the structure, you should be able to distinguish alloy and a pure metal. A pure metal contain same size particles, the lattice of the positive ion. So all the particles are of same size for a pure metal. But if it was an alloy, alloy means mixture of the metal, but don't add like too many impurities. It's like any one or two impurity particles of another substance is there, but not too many. So this is a simple structure of an alloy. And alloys are generally harder. Why alloys are generally harder? Because different size layers, different size of particles, more friction between the layers, and the layers can not slide over each other. So as you can see, the structure of the alloy, as metals are there, lattice of positive ion, and different size particles are present also. So alloys are generally harder because greater friction between the layers. So reactivity series, what you have to do, you have to place in order of reactivity potassium, sodium, calcium, magnesium, iron, hydrogen is there, then copper, by reference to the reaction, if any, with metal or steam, and with dilute hydrochloric acid, and reduction of their oxide with carbon. if they ask to draw an alloy, normally you don't have to draw the delocalized electron, because delocalized electrons are there within the structure, but you don't have to show. Barely what you're showing in alloy, you're showing the main structure. There will be delocalized electron, but we are not representing that. So if they ask to show delocalized electrons as well, the structure of an alloy with the delocalized electrons, just shade the region to represent these delocalized electrons. But normally they don't ask to draw. They simply say draw a simple structure of an alloy. So same way as it is shown in the figure, you will draw. Then place in order of reactivity potassium, sodium, calcium, magnesium, zinc. So metals can be arranged in order of the reactivity series. We have potassium, sodium, calcium, zinc, iron, copper, as we discussed the reactivity series. And non-metal hydrogen and carbon are often included in the reactivity series. So when we write the reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum will be there. Position of the carbon, where the carbon is placed. Carbon is more reactive than zinc. So this is the position of carbon. And what is the position of hydrogen? Hydrogen is more reactive than copper. So this is the position of hydrogen. So all these metals or their oxide, because if we have potassium oxide, sodium oxide, they are, so we cannot use carbon to reduce them, but less reactive than carbon can be reduced by, their oxides can be reduced by heating with carbon. And describe the reactivity series as a tendency of a metal to form a positive ion. So when we say as we go down in the series, the reactivity decrease. So what is the meaning of reactivity decrease? It means at the top we have the most reactive metal, and at the bottom we have less reactive metal. And what is the tendency of the metal? Metal tend to lose electron. So potassium can lose electron easily as compared to that of platinum. And always the more reactive metal displaces the less reactive metal from its compound. So if we have, say, zinc oxide and we use magnesium, so magnesium is more reactive, so magnesium will displace the zinc. As a result, it will form magnesium oxide plus zinc metal. So always the more reactive metal displaces the less reactive metal from its compound. Then describe a reactivity series as we discussed the aqueous ion and metal oxide. Describe and explain action of heat on metal hydroxide, metal carbonate, and metal nitrate. So you have to learn this table. For potassium and sodium, again this is from reactivity series. For potassium and sodium, their hydroxide are stable to heat. But from calcium to copper, like from C to C, when you supply heat energy, it will decompose. Calcium, magnesium, copper, they all decompose in this way. When metal carbonate or metal hydroxide, so when we have metal hydroxide or metal carbonate or metal nitrate, so you have to learn this table. Metal carbonate decompose into metal oxide and carbon dioxide. Metal hydroxide decompose into metal oxide and water or steam. So from calcium till copper, all these elements, not this sodium is not there, they decompose in the same manner. But if we have metal nitrate, potassium and sodium nitrate will decompose into potassium nitrite plus oxygen, and this is the sodium nitrate. It will decompose into sodium nitrite plus oxygen. Whereas other metal nitrate on heating gives metal oxide plus nitrogen dioxide. So nitrogen dioxide is a brown gas. Sometimes they ask, we have a metal nitrate and we are supplying heat energy. What is the observation? So observation is that the, this will release on heating, release a brown gas, which is nitrogen dioxide. And nitrogen dioxide is a non-metal oxide, which is also known as acetic oxide. So it will have effect on the indicator paper. Then extraction of the metal, how we extract the metal, describing a ease in obtaining the metal from their ore relative to the element to the reactivity series. So we have this reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, platinum. So for more reactive metal till aluminum, because they are highly reactive metal, so what we can do, we can remove them by electrolysis. For less reactive metal, the elements which have reactivity less than carbon, we can simply heat them with coke, and the least reactive metal, we can simply heat them, even we don't need carbon. If we supply heat energy, it can decompose into metal and oxygen. So describe the ease in obtaining a metal from their ores relating the element to the reactivity series. While lithium is not included in the reactivity series, because this reactivity series is a elements for elements which you are studying in your course. Like, you're not studying mainly, you're only learning the flame color for lithium, but you're not learning the compounds, the uses, the formation of lithium compound. That's why it is not included. This reactivity series is given for the elements commonly you are studying throughout the course for the metals. Then describe an extraction of zinc from zinc blend. So how we extract zinc from zinc blend? So first what we do, zinc sulfide is turned into zinc oxide by heating in the presence of oxygen. Then zinc oxide is either reduced by carbon monoxide or dissolved in sulfuric acid and then electrolyzed. But normally we heat with carbon monoxide instead of directly doing electrolysis, because electrolysis increases the cost of extraction. Then describe and state essential reaction in extraction of iron from hematite. So what happened? Extraction of iron in a blast furnace from ore iron oxide. So in a blast furnace, very high temperature, iron oxide is reduced with carbon. First, iron ore, coke, limestone are added into a blast furnace. When hot air enters from a bottom, it goes to the top of the furnace. Oxygen react with coke to form carbon dioxide, which may increases the reaction, as the reaction is exothermic for formation of carbon dioxide. Then ca carbon dioxide further react with coke to form carbon monoxide. Carbon monoxide is a reducing agent which react with ore of iron and reduce this iron oxide to iron. But some of the carbon will also be reduced, because carbon itself is also a reducing agent, and molten iron runs at the bottom of the furnace and then we remove from the furnace. But the iron which we extract from the blast furnace is not a pure iron. Why? Because it contains unreacted carbon as well. Describe the conversion of iron into steel using a basic oxide. So that basic oxide is calcium oxide and oxygen. So how we convert iron into steel? So carbon is removed from a molten iron by blowing oxygen, because carbon react with oxygen, give carbon dioxide, and oxygen can react with carbon, give carbon monoxide or carbon dioxide, and both gases escape from the iron, and sufficient oxygen is used to produce steel of desired carbon content. And how we remove impurities, acidic impurities are removed by using a basic oxide, which is calcium oxide. So calcium oxide react with acidic impurities and remove from the mixture, which is stronger reducing agent. Carbon monoxide is stronger reducing agent than carbon, because in carbon it is 0, but in carbon monoxide, when we write the oxidation number, each oxygen is -1, two oxygen will be -4, so that is +4. Like changing carbon monoxide, this is -2, so this should be +2. Like the tendency, already oxygen is there and it is not a stable compound, so it can gain oxygen easily. That's why we call that as a good reducing agent. Known that aluminium is extracted from ore bauxite by electrolysis. So what we do, extraction of aluminium, what we do, first we have a metal that is more reactive, we extract by electrolysis instead of reacting them with carbon. And aluminium ore, it also contain iron oxide. Aluminium oxide is amphoteric, so it can react with both acid and alkali. And iron oxide is a basic oxide, so it can react with acid only. So first what we do, when we add an alkali, aluminium oxide will react, whereas iron oxide does not react. So we can filter to remove iron oxide from aluminium, and then we do electrolysis of this aluminium oxide. But aluminium oxide, pure aluminium oxide, is having a high melting point. Before that we add a cryolite, and when we add a cryolite, it lower the melting point and it concentrate the ore, increase the conduction. Aluminium ions move towards cathode, whereas oxygen ion move towards anode. But anode must be replaced regularly. Why? Because the oxygen which is produced at anode, due to very high temperature, it's not like oxygen react with carbon at normal temperatures. Due to high temperature, it react with carbon, so the anode size will decrease. Then discuss advantages and disadvantages of recycling metal. Limit to iron and steel and aluminum. So what are the advantages and disadvantages of recycling the metal? What are the advantages of recycling? Basically, require less energy to melt and remold the metal, that it does not to extract into new metal from their ore. Like we don't have to extract the metal. And what we have limited supply for metals which we are extracting. So few quarries or mines needed, then they extract the metal, so less noise and dust pollution is there. And recycling allow the waste metal to be reused and save money and helping the environment and supply the valuable raw material. But what is a disadvantage? It required energy to transport or sort out the metal. You don't have to learn, you just have to learn the advantages and disadvantages, but not the process how it is done. So disadvantage of recycling the metals such as iron, steel or aluminium, it require energy to transport. Like sorting out is there. First you have to sort out the metal, like this material is made up of iron, this is made up of, this is iron, steel, aluminium, so you have to sort out. That is it. And another, it required energy to transport the metal from one place to another, and different metals required different amount of energy to recycle. Then uses of the metal, name the uses of aluminium in a manufacture of aircraft because it is strong. So sometimes they ask why aluminium is used for manufacture of aircraft body. So because of its strength and low density, not only low density but strength. Why it is used for food container because it resists corrosion. And explain the uses of zinc for galvanizing or for making brass. Basically, what is brass? Brass is a mixture of zinc and copper. So in galvanizing, what we do, we coat the iron which we want to protect by zinc, and zinc is more reactive than iron, so zinc will rust instead of iron, or zinc will sacrifice instead of iron, and it will protect the iron from rusting. Whereas brass is a use like it's a mixture of zinc and copper, and the uses of the copper related to its properties. So where we can use copper with reference to its property. Aluminium is also used for overhead cable. Overhead cable, like high tension wire, you will find when you're traveling on highway, you'll find there are high tension wire cables are there. Why these high tension wire? It should be low density. Why low density? So we can easily lift it up, extend and lift it up. And why? Second thing, it should be a good conductor. So high tension wire, as they are lifted up, so when they have low density, they will have less matter or less mass. That's why it can be easily lifted up. And second thing, it is used as a conductor, so it should allow the heat energy, electrical energy to pass through, or good conductor of electricity. Name the uses of copper related to its property, like electrical wiring and cooking utensils. So why copper is used for electrical wires? Number one, it's malleable, that is one thing, and good conductor. And the second thing, again, why it can be used as a cooking utensil or pan, because it is good conductor of heat, and it is also malleable. For wires, it is ductile and good conductor, and for cooking pans, it is malleable and good conductor of heat energy. The term ductile means when you can stretch something and make wire, like make a cylindrical pieces or wire. When I apply force and I can stretch a material, we call that as a ductile. So material can be stretched or drawn into wire, that's called ductile. And if a material is hammered into shape, like you apply a force and you make certain shape, we call that as malleable. So malleable is deformed under compression, where ductile is deformed under extension. Then name the uses of the mild steel, low carbon steel, and stainless steel in chemical plants. So low carbon steel, when you check, as we have different types of steels, low carbon steel, why it is suitable? Because for what are the properties? First, it is tough. Tough means greater amount of force is needed to break, or it can undergo considerable deformation before it break. That's why we call tough. Ductile means it can be hammer stretch into wire. Malleable means can be hammered into shape. Good tensile strength means greater amount of force is needed to break this, and we use for car bodies or machineries. Stainless steel, which is an alloy, contain nickel, chromium. It resists corrosion, that's why we use in chemical plants and cutlery. There are also different types of steels. Describe the idea of changing the property of iron by controlled use of additives to form steel alloys. Like there are different types of steel depending on other elements mixed with iron. Example, if chromium and nickel are mixed to make stainless steel, which is resist to corrosion. and a mild steel, a low carbon steel is about 0.25 carbon is there, therefore it can be easily shaped. A high carbon steel about 2.5% carbon, because higher impurity the layers cannot slide over each other, so it will be relatively hard. So depending on the element used in addition to iron to form steel, the property will different, meaning have different uses. And alloys are generally harder compared to that of pure iron, because the layers, as this is if they ask why like steel is harder than pure iron, so what will the reason? Because different sides metal lines are there, disrupt the regular arrangement of the layers and preventing the layers from slide over each other, so it will be hard, the alloy will be harder compared to pure metal. This was about the decomposition of thermal decomposition of hydroxide metal. Sodium and potassium does not decompose. Nitrate. Steel is an only alloy which is a mixture of iron and carbon. So steel is also known as alloy. But if they are, this is the only exception is there. Steel is the only alloy which is a mixture of metal and non-metal. All other alloys are known as a mixture of the metal. So sodium and potassium decompose to metal nitride plus oxygen, and carbonate are stable to heat. This is a table to know the color of the compound. Like how I will know what is the color of copper nitrate. So copper from here, nitrate. So copper nitrate is blue. Copper chloride. Alloys are not chemically bonded. It is just a mixture. There is no chemical bonding in alloys. Copper bromide is black in color. Copper sulfate is blue in color. Copper carbonate is green in color. Copper hydroxide is blue in color. And copper oxide is black in color. So very few substances are there you can see in this table which are colored. So it's better you learn the color of these compounds. This is a composition is given for different alloys and their uses. Then the next topic is about air and water. So first thing, describe a chemical test for water using a cobalt chloride or copper 2 sulfate. So what is a chemical test for to check the presence of a water? When we add cobalt 2 chloride, you should use the term anhydrous. It will turn from cobalt chloride turn from blue to pink, and copper sulfate will turn from white to blue. Discuss the implication of an inadequate supply of water limited to safe water for drinking and water for irrigating crops, and describe an outline treatment of the water supply in terms of filtration and chlorination, and name some of uses of water in industry and home. So water is essential for the life which human needs. Drinking water with a low level to which is having a dissolved amount or dissolved salt should have a very small quantity. How we carry out a filtration. So water of correct quality is essential for the life, so it must be freed from the poisonous salts and harmful microbes. So first what we do filtration to remove the insoluble substances, and then we use chlorination to kill microbes. We can sterilizing agents such as ozone, ultraviolet light, or chlorine. This is a simple structure which shows the purification of the water. Then the uses of the water related to, as you have to specify the use of the water. In industry, the water is used as a solvent, like to ultraviolet light will not make it radioactive. Ultraviolet light does not allow the bacteria to grow. That's why, like, you will find some of the surgical apparatus they are keeping in a box which is having a ultraviolet source. So it is used to kill bacteria. In industry, we use water as a solvent as well as a coolant to cool down the industry. We use water, and in home we are using water for drinking as well as for washing. Then air, state the composition of the dry air as being 78% nitrogen, 21% oxygen, and remainder is a mixture of noble gases and carbon dioxide. And describe the separation of oxygen and nitrogen by fraction distillation. So how we separate these fractions? The technique which we use of fraction distillation is used. So fraction distillation of a liquid air, which is used to separate oxygen and nitrogen from each other. Oxygen has a boiling point higher than nitrogen. Air liquefied at minus 200. So when the fractionating column temperature is increased until the nitrogen boil and rises, so nitrogen boiling point is minus 196. So it will first what we did, we cool the air to a temperature of minus 200, so air is liquid. But what happened, as it gain energy, its temperature start to increase. As its temperature is increasing, once it reaches minus 196, so nitrogen will convert from, because that's a boiling temperature of nitrogen, so nitrogen will convert from liquid to gas. And once its temperature reaches minus 183, the oxygen start to convert from liquid to gas. Name some common pollutant in air as being carbon monoxide. So carbon monoxide, due to incomplete combustion, carbon monoxide is there, can cause suffocation. Sulfur dioxide coming from fossil fuel containing sulfur, giving leads to global warming. It leads to acid rain, not global warming. Oxides of nitrogen, it's coming from car engine due to the oxygen and nitrogen reacted in the car engine at high temperature. That can also cause acid rain as well as photochemical smog. And lead compounds. Lead compound is not originally present in the fuel, it is added to make the fuel less volatile, and it is released and it can cause or damage the nervous system. So these are some effects, as you can see, for different gases. Then state the source of each of these pollutant. Carbon monoxide from incomplete combustion of carbon containing. Photochemical smog. The term, actually, smog is a combination of two words, smoke and fog. When smoke and fog mix together, what it will form? It will form smog. Like you have smoke and you have fog. So when mixed with each other, that is called smog. Why we called it as a photochemical smog? Because it does not allow the light to pass through. It reduces the amount of radiation which are able to pass through. That's why we use the term photochemical. You can also say smog, but not smoke. Smoke is, because smog is a combination of smoke and fog. Describe and explain the presence of oxides of nitrogen in the car engine. So how these oxides of nitrogen are formed and how it is removed. Oxides of nitrogen are formed when nitrogen and oxygen react inside the car engine due to electrical uh, discharge or spark. And these oxides are oxidized, reduced to nitrogen. which is by using a catalytical converter. So nitrogen monoxide is reduced and carbon monoxide is oxidized to carbon dioxide, which are less harmful compared to other gases. State the condition required for rusting of iron. So for rusting of iron, what are the conditions required? For rusting of iron, both oxygen and water both should be there. And describe and explain method to prevent the rusting. How we can prevent rusting? We can keep oxygen and water either by painting it, by covering, by coating with plastic or another metal, or store in vacuum container also can be done, but that's practically a difficult technique to create a vacuum and store the iron. Describe and explain sacrificial protection in terms of reactivity of the metal. What happened in and galvanizing as method of preventing rust. So galvanizing a less reactive metal coated with more reactive metal to prevent it from rusting. For example, iron and steel normally are coated with zinc. This works because a more reactive metal is oxidized by oxygen in air, or rust we can say, and protect the less reactive metal. So it is similar to that of sacrificial protection. Then nitrogen and fertilizers, nitrogen, phosphorus and potassium, NPK, are essential elements to provide the nutrient for the growth of the plant. And describe displacement of ammonia from its salt, how ammonia is displaced from its salt. When we react with sodium hydroxide and heat, it will release ammonia gas. So ammonia mine is displaced. Then manufacture of ammonia by a Haber process. When nitrogen react with hydrogen around 450 degrees centigrade and 200 atmospheric pressure, it forms ammonia. The iron is used as a catalyst. The reaction is reversible. Why coating with more reactive metal? It will be basically, if we coat the iron with more reactive metal, even if it is not completely coated, like you have a strip of more reactive metal on the iron surface, then only even that will also will protect the iron from rusting, because that is a more reactive metal, so it will oxidize and iron will not rust. So even a small quantity of a more reactive metal is used, that will protect the iron from rusting. But yes, it can increase the cost for protection. That's why it can be painted, or less reactive metal surface can be used. Then carbon dioxide and methane. State the carbon dioxide and methane are the greenhouse gases. Production of carbon dioxide by complete combustion. Production of a methane by decomposition of vegetation or plants, or waste from digestion of animals. Or animal waste decompose give methane, and decomposition of plants. And describe the carbon cycle. The carbon dioxide emitted in respiration and absorbed in to make carbohydrate in photosynthesis. Plants also respire. Plants also contribute to emission of carbon dioxide, but they absorb